Alright guys, here we are with the Unit 11 review for area and perimeter. Well, it's mostly area. Alright, so let's get going. Again, I think this format of having the worked out answer key and just kind of explaining as I go just works easier for me now than trying to write everything myself with the pen on the iPad. Number 1, Mark orders a 12-inch diameter pizza. He divides it equally into slices by cutting every 45 degrees around the middle of the pizza. What is the area of each slice? Of course, you're going to use area of a sector, which is on your blue formula chart. So the arc degree, I didn't put that on there. I mean, I didn't write it out, but, you know, let's see. See, look at that wonderful pen already. The arc degree is 45 because it literally tells you it cuts every 45 degrees around the pizza. And with the 12-inch diameter, that makes your radius 6. So I know the last couple times we've done examples, I've told you to put things what we call in terms of pi, meaning pi stays in the back. But in a multiple choice test, you could get either one. So I showed you both answers, but you see 45 over 360 times pi times 6 squared. So on the first one here, you see I did 6 squared times 45 over 360, which leaves you the improper fraction 36 over 8, pi, which reduces to 9 over 2, and then if you multiply that out, you get 14.137. So both possibilities, but this formula is on your formula chart, so make sure to use it. Number 2, exact same idea, just a different type of problem with it. Circle C with diameter DG is shown in the figure below. To the nearest hundredth of a centimeter, what is the area of the sector ECF? So, when you're given these, follow the letters. It's always in geometry, when they give you letters, trace them, right? ECF, so it's that sector right there. Originally, all you know is this is 90 degrees and this is 20. So over here you see 90 plus 20 equals 110. And then 180 minus 110, of course, being 70. So 70 is the arc degree. You put that over 360. And the radius is 8. And so this time, because it says to the nearest hundredth, I did 70 over 360 times pi times 8 squared, multiplied everything through, and you get 39.095. Yeah. Number 3, rectangle ABCD has a width 3 times as wide as rectangle EFGH and a length 4 times as long. The area of the rectangle ABCD is how many times larger? So what I did here, ABC is obviously the bigger one. So first I drew, let's see, get the pen, ABCD. Then I drew the little one. Oh man, this pen. Alright, so ABCD is the bigger one, EFGH is the smaller one, and I used X and Y just as generic variables. So it says that the width is 3 times as large. So over here you'll notice that makes this 3x. And it's 4 times as long, so that makes it 4 times y, right? And then how do you find area? Length times width. So on the little one, you would get x times y. On the bigger one, you get 3x, times 4y, and that gives you 12xy. So how many times larger is it? 12, because this is regular xy, that's 12xy. So that's one way to work those problems. And then everything just leaves, of course. Next one, number 4. A game show has a gigantic circular spinner divided into 15 congruent sectors with a diameter of 24. What is the exact area of each sector of the spinner? So again, with a diameter of 24, your radius is 12. The arc degree you'll find by doing 360 divided by 15, because there's 15 equal sections. So the arc degree is 24. and then again the formula, just like the first few problems. So again, the exact area usually means you don't want to round it, but again, I showed you both options. 24 over 36 times 12 squared is 144 over 15 pi. If you multiply everything out, you get 30.159. Okay. Number 5, again, describe how the area of a rectangle will change if its width is doubled but its length is halved. So I draw A, the rectangle, and so the width, it doesn't matter really where you put length and width, which way you look at it, but one of them is doubled, one of them is halved. So if you think about what that would do, right, you'll notice here, this got twice as long, this got half as big. So it basically kind of rotated it, if you will, even though it's supposed to stay sitting the way it is. Well, if we do that same process, let me zoom in here a bit. X times y on the original one, half x times 2y, takes you right back to xy. It didn't quite come out here. So the area stays the same, right? Because you get xy out of both of them. So again, just multiply the values and see what you wind up with. Most of the time you'll get a bigger or smaller, just depends on the problem. Number 6, a square has side lengths of m feet. If one pair of opposite sides is doubled and the other pair is tripled, what would the new area of the changed quadrilateral? So again, you'll notice some of the problems we're focusing on. We have area of a sector several times. Now we have the change in measurements. And again, to me, the easiest way to do this is this. Right? Square m by m, all four sides are m, but I just use it as reference. One side is tripled. One side is doubled. When you find area, you get m squared for a and 6m squared. So the new area would be 6m squared. Now 7, we have some regular polygon formulas, 1/2 AP. Again, I'm pretty sure on this test you're going to have apothem and side lengths given to you. We'll double check that, but I'm pretty sure. So right here, apothem, I keep forgetting the pen. Apothem 5, perimeter 5 times 13 is 65, 1/2 apothem perimeter. All right, pretty straightforward. No, I take that back. There is one we're going to have to solve. We'll talk about on the back page. John owns a piece of rectangular land that is 20 by 30 miles. If he cuts down the size of the land by cutting each dimension in half, what would be the area of the new tract of land? So again, same type of problems, right? 30 cut in half to 15, 20 in half to 10, 600 becomes 150. This is where you square the scale factor, but you see it because half of 600 would be 300, right? And so it's half and half, which is a fourth. Honestly, if you just draw the picture like this and do what it tells you, it's much easier to work with, but that's what's going on. All right, so that's number 8. On to page 2. All right, guys, here we are on page 2. What is the area of the composite shape? We had this one on a worksheet, pretty simple. All right, you draw the line here, you have a triangle, and you have a square. Triangle, it's 14 here, but then you have the 6 on both sides, that makes 26. Tells you clearly right there the height is 21, so 1/2 times 26 times 21 is 273. The square is 14 times 14, that's 196, and just add them up. All right, pretty straightforward. What is the exact area in square centimeters of the outer shaded region? So you'll see here that the whole circle is 8. The radius is 8. The little circle, the inside unshaded part, is 3. So big circle, pi times 8 squared. And again, when they talk about exact area, usually you don't have decimals. So 8 squared times pi is 64. The inner circle has a radius of 3. 3 squared is 9. I forgot to put the pi symbol. It should be 55 pi, not, just 55. I'll write it again down here, 55 pi. Find the area of the following equilateral. Okay, so this is one you're going to have to solve. All you have is the apothem. But remember, in an equilateral triangle, all these angles are 60. When you draw this line to make a right triangle with the apothem, which first of all, your apothem is the 2.9, This angle down here is 30, so you get a 30, 60, 90, but it's kind of laying down. That's x, 2x, x square root of 3. So this is 5.8. It's hard to see the decimal there, even though we don't really need that. Other than this becomes 2.9 square root of 3, and you double that, and one side is 5.8 square root of 3. So then to get the perimeter, I don't know, I didn't write it out. It's 3 times 5.8 square root of 3, which gives you 30.138. So 1/2 times apothem times perimeter. Again, special right triangles, they're on the formula chart. Make sure you understand them. Quadrilateral PXTU is a rectangle. The quadrilateral UCXD is a rhombus. Find the area of the shaded region. So this is 10. If this is 4, this makes 6, which makes this 6. So the whole length across is 16. That's 8. So the big rectangle, 8 times 6 is 128. This is a parallelogram. You can use base times height with base is 10, height is 8. You could break it down into a rectangle and 2 smaller triangles, however you want to look at that. Either way, the unshaded part is 80, so 128 minus 80 is 48. Okay, and you see the work there. Find the area of the unshaded part of the rectangle. So it's kind of hard to see, but just so we're clear, what's intended, let me see, to be shaded is this inside shape, basically. So it's like the unshaded part is what's around it, right? So the big rectangle, 30 by 50, that's 1,500. You see that there. And then the inside shape, the radius of 7 and 7 gives you the side of the rectangle at 14. So 14 times 21 for the rectangle is 294. The 2 half circles combine to make one circle, pi r squared. Use the decimal because we're adding numbers. That gives you 447.938, and then you subtract 1,500 minus 447.938, 1,052.027. Find the area of the shaded region. This is a big square. If it's 12 across, then that means each circle has a diameter of 6, and the radius of each little circle is 3. So the big square is 12 by 12, that's 144, you see that. So in each circle, you can do pi times 3 squared, and there's 4 circles, and then times 4. Altogether, you get 113.09, and then you just subtract. Or 903 maybe? My decimal's kind of hard to see, but you get the decimal and you just subtract it, right? Pretty straightforward. So there may be one like this on the test, although this one gives you what you need. So that triangle one would probably be the only one similar where you have to solve something. Apothem's 3, side length is 6, so it's 6 times 4 for perimeter again. You can check yourself. We talked about this. You know 6 times 6 is 36, but, you know, they want us to use a formula, 1/2 apothem perimeter. Pretty easy. Guys, use the formula chart. Know what you need to plug in. This should not be that difficult. You know, you have the calculator. Show work on free response. Multiple choice should be helpful. All right? Good luck.